Hey guys, welcome to this Oracle DBA series. In this video, we are going to see a troubleshooting session of a real-time DBA who is troubleshooting a particular issue. So here the scenario is when a DBA wants to log into the database and check any performance issue, right? He needs to identify a specific session which is responsible for the performance issue, right? So which means what he will check first. He will check the particular session or the SQL statement or any task which is consuming more resources on the database, right? So to particularly pinpoint the bottleneck, right? So whatever specific session which is causing the issue, right? So there will be some root cause. So not every sessions which are connecting to the database may be the problematic sessions, right? It may be one or two sessions, or it may be a couple of sessions, not all, right? So almost 20% of the causes will be causing the 80% of the problem, if you see Pareto's rule, right? So you don't need to focus on all the 100% of the tasks which are running on the database. You need to focus only on the minority, and that minority will be the cause for the performance issue. So now I'm just going to run a sample workload on the database. Okay, so yeah, just you can imagine this session as a real-time DBA troubleshooting session. So you are DBA now, you're going to you got a complaint from the application and the end user and business saying that the database is having a bad performance issue, and they want you to involve in a call, and you join the call. Okay, so all the management and all the people are here. So in this case, you need to troubleshoot the issue, and if at all you don't need to give a solution, but still you need to give some identification, right? So you need to analyze something, and you need to diagnose the issue, and you need to tell something, justify something, right? So solution is the final part. Okay, we cannot directly implement solution all the time, right? So if it is a production system, always we need to find the cause of the issue first, right? So almost majority 90 to 95% of the focus will be on finding the cause. Okay, solution, once you identify the cause, giving solution, that's not a big deal, right? And also implementing the solution is a big deal, right? So if it is a production system, we cannot directly go ahead and increase the CPU as easy as we can, right? We cannot directly modify a parameter, right? Because modifying one parameter may cause impact of all the other sessions as well, right? So we need to consider all the pros and cons before we implement a solution. Okay, but we can suggest some solutions. So after that, it is a collective work. So all the people, the manager, the management, and we need to tell the impact to the management, saying that if we implement this solution, these are all the negative outcomes that may happen, and based on that we need to implement a solution. So now we are going to focus only on identifying the cause, right? So how we can identify any session, right? So I'm just going to give you a quick troubleshooting way to identify this. Okay, so we have active session history in the Oracle database. So it is part of a diagnostic pack, and it is completely licensed. Okay, so if your organization or wherever you are working, if they have a diagnostic pack license from the Oracle, then you will be able to query all these views. Otherwise you will not be able to query this. So you should use stats pack report, but I would say it depends on the organization. So having this pack, paying license for this pack, it's not a big deal. But when you are losing data in troubleshooting, then you are losing the business money, right? So when the database is in trouble, and when you are not able to identify when you don't have the tools to identify the cause, then that will become a big problem. So I would say better having this license would be fine. Okay, that depends on the individual and the organization. So we have a set of hash queries. Okay, so this will directly narrow down the sessions or narrow down the issue to the root cause. Okay, it is just a 5-minute job, so you can keep this script as handy. Okay, so I can put it on the description if you want, or you can just see the script and you can write it down. So imagine again you are in the situation in the call, and you need to identify the cause. Now I have generated the sample workload. Okay, so let me again generate the sample workload. Okay, and before that, let me take the sample time. That is very important. Not the sample time, the current time. So always, whenever you are troubleshooting any issue, you need the information. Okay, so what are all those information? So information is always helpful, right? So you need to collect the timings of the start and end time of the issue. So even if the application team is complaining about a particular issue, you still need to ask the time during when the issue had occurred, right? So here we are only simulating the test case. So here there is no application team, so we only have to record the time. Okay, so consider okay, so okay, consider this as the start time. Okay, and let the script run. So consider this script as an application job. Okay, so some business application is running, so it is just serving the end customers. So you can take this application as any this job as anything, any sector, like it is a manufacturing industry. So if some manufacturing industry requires some billing part or some invoice part or processing, something like that. So let me again execute it. Let me do one thing. Let me increase the number of loops. So that it will run for a longer time. Okay, so now the job is started. Okay, so when the job is started, after some time, just imagine after 5 minutes or 10 minutes of this job getting executed, user is complaining about a performance issue. Okay, so now I have joined the call and I have all these scripts in handy, and I got the time. Okay, time of the issue. So you just take this time. Okay, and you just input the time here, date and time here. I also need the end time, right? End time of the issue. So I can just take a 10-minute interval. Okay, so here what will be the current time? See, the database itself got hanged. So this simple query is taking a longer time for executing. Okay, so this is kind of a real performance issue. So now I need to know the end time of the issue. So I will fill the end time here. Okay, so this is an active session history view. Okay, so first I am just collecting the sample ID. Okay, sample ID is the samples collected for the ash. So what is ash? Ash is completely a sample based tool. Okay, so every activities which are happening on the database are sampled in the form of statistics, right? So if you see in statistics theory, there will be a sampling rate or sampling concept. So you can use that sampling concept. Oracle uses that sampling concept to collect the it is similar to snapshots, but it is not about time. Okay, so these samples are collected in some certain intervals, and it is more granular or more in-depth compared to AWS snapshot. Okay, so once you get the sample information with the time, then what we need to do, we need to find the weight class. Okay, so every performance issue are categorized and they are instrumented. Instrumented means they are recorded in the form of weight events. Okay, so the database either uses CPU or it will wait on something. Only these two states the database will be doing. Okay, so if the database is using the CPU, then that is a different case. But if the database is waiting for some reason, then you need to know the weight class. Okay, Oracle has categorized each and every reason with the weight class ID. Okay, say for example, you can take a real-time example. So you are going for a restaurant, right? So you are waiting in a queue. Okay, so here queue is one form of wait, right? And you may wait for different reasons. It is not only for paying the bill. You may wait for getting your order. You may wait for paying the bill. You may wait for choosing the menu, choosing the food from the menu. You may wait for the waiter. So there are a lot of reasons for which you wait. It is not only that you wait in the queue for paying the bill, right? So likewise, you can take the same example. Oracle database, when it is to be simple, Oracle is only processing the SQL. That is the main job of Oracle, right? So to process that SQL, you can take Oracle as the restaurant and all the SQLs as the customers who are waiting in the restaurant. So each and every SQL or each and every customers. So each and every customers may be having different reasons to wait, right? So if one customer is ordering some rare dish which may take a long time, then it will take some time, right? So likewise, each and every SQL will be performing different operations like sorting, aggregation, modification, right? So the weights will be something different. Okay, so in some restaurants, if you go, they will be having multiple people, multiple workers, so they will prepare the dish in a faster way. In some restaurant, people will be less, right? So likewise, if Oracle database has more resource like CPU, it will run in parallel. So it will process the data in a faster way. So you can take the real-time example like this. So likewise, Oracle has categorized different weight class. Okay, so like how you are waiting for a bill or waiting for a dish or waiting for the waiter. Okay, so all these reasons are categorized. So you are finding out the weight class with the help of the sample that you are collected. So here minimum sample is the issue start time, and maximum sample is the issue end time. So here you can take the delta value. Okay, so delta means end time minus the start time, which is the delta value, right? So if the issue starts at 4 and if the issue ends at 5, then 5 minus 4, which will be 1 hour. So 5 minus 4, which is 1 hour. So the interval, the time duration, what is the interval or the duration of the issue? So that we need to find out, right? So you can take the sample ID for those intervals. Then you are substituting to find the class. So once you find the class, you need to find the event, right? So similar to how I mentioned, like paying the bills. Okay, so you can categorize each and every events like this. Say for example, so in a real-time restaurant example, paying bill, So getting bill, method of payment. So even if the internet connection is slow in your mobile, then also that is also kind of wait. You are waiting for the internet connection to complete. So you can take these as a class. You can categorize everything as a class. So these kind of waits will come under payment class. Okay, and likewise you can take the workers, the chef, the waiter, all those people. So if they are taking more time, it is the problem. It is not the problem of our case. It is the problem of the restaurant. So it is all backend. Like waiter, if the waiter is taking long time, or the chef is taking long time to prepare the food, or if the food is having shortage and they need to buy it from somewhere else. So these kind of waits will come under backend, which means the restaurant itself is delaying, right? So again, so you need to invite someone. Okay, so you are saying after some time you are telling the restaurant saying that people will come, so you are telling them to wait for some time, other people to come. So this is another kind of wait. So you are categorizing all these waits. So these are worker waits, these are payment related waits, these are acquaintance or friend, waiting for the friends, right? And under these categories, under this class, you have other type of other subcategories of waits. Okay, so here you can take the same class like this. Okay, and event as the actual event. Okay, so if you just we have a view to check the class and the events. Okay, we call a session event. Okay, so here we have wait class. Okay, and we also have event. So if I just say select distinct wait class from so Oracle has categorized each and every class like this. Okay, system IO. System IO means these are all these wait events are related to system, which means the operating system. Scheduler means only the wait events which are related to scheduling will be recorded under this class, like job scheduling, CJQ process, J0 process, all the auto task, like backend tasks. All these are scheduler jobs. Okay, network comes under network wait. So if the SQL net message from client, we have a wait event. So if the internet connection is if I'm connecting from remote place, and if I'm connecting to the database, that if the local internet is slow, then that will be a network connection for the client, not the database. So likewise, application related issues. So the application related issues are related to NQs, right? So if multiple insert, update, deletes are happening, then all these are application related. So if a lot of commits are happening, that will come under commit. User IO means like all the data file reads, right? So if server process is reading the data file, so these are user IOs. Other concurrency means logs, like latch, library cache logs, and idle means idle event. Configuration means like increasing the data file size. So if there is no space on the data file, or if the read log file size is not efficient, right? So these are configuration related classes. So likewise, you can also check the distinct event, but we have almost thousands of wait events in 19C, and it will go on. It will increase further. See, you have almost 4,000 wait events. Okay, so all these 4,000 wait events are categorized under these 10 wait class. Okay, so each and every class will be having a bit of wait events. Say for example, system IO may be having 500, scheduler may be having 100, network may be having 50, application may be having 500. So something like that. Okay. So hope it is clear now. So yeah, now the job would have been completed. Okay, so we just need to record the current time. Just we can take 1 or 2 5 minutes before. Okay, that's fine. 16:41. So I have taken the correct time. Okay, so once you take the correct time, you need to identify the sample ID. Okay. So since we are simulating the issue and also finding the sessions, that is why it is taking too much of time. But when you are a DBA and if you are joining a call, then it will not take a longer time. Okay, you don't need to get embarrassed in front of others when you don't know what to do, right? So always, even I was in a situation like that earlier. I will be paged in some call and immediately they will say they will scream because their customers are not happy and they will just shout, right? So if we have a proper method to diagnose and justify something, at least we can manage, right? So immediately if we are involved and if we don't have any proper organized way of identifying the sessions, then it will be a problem. So now we identified the class, wait class. Okay, wait class is scheduler. Okay, so you can now understand, right? You got some idea like what exactly is happening on the database. So now I know that the performance issue is due to some scheduler jobs. Okay, now I need to find out, right, whether it is a backend scheduler jobs or application scheduler jobs. So even in scheduler jobs, there are a lot of scheduler involved, right? Backend scheduler means if I schedule maintenance job in my database, right, like running the statistics job, running the SQL tuning advisor jobs, running all the other backend jobs in the database, then that will come under backend scheduler. Application scheduler means application itself will schedule jobs on the database. So this is business, this is front end, but this is backend, which means this is internally executed by Oracle, right? So if it is a backend job, then a DBA is responsible. Okay, so everyone will question DBA saying that why you have scheduled this scheduler job during the production hours. So if it is an application job, we can put the blame on application, right? So yeah, so once we identify the class, then we need to identify the event. Okay, exact event which is responsible. This will easily further help us in narrow down the cause. Okay, so yeah, let me just, yeah, here the wait class that I have chosen is wait class ID is something different. That's why I'm not getting the proper information. So you need to substitute the wait class ID as well. Otherwise you will get the wrong information. So now if you see almost 8,000 samples are collected for resource manager CPU quantum. Okay, so if you comparatively see the other events, it is just 100, direct path read is 100, 20. So you can just leave all these other unwanted information. So these are just regular activities which are happening. So this cannot be avoided. But if you see this, it is somewhat significant, 8,000. If you compare it, compare this 8,000 with the other numbers, it is somewhat, you cannot even imagine, right? Almost 80 or 100 times more than the other events, right? So now we identified the exact event. Okay, so now you can just go and check what resource manager res mgr CPU quantum is. So this is completely resource manager event, which means in Oracle database we have a tool or an algorithm called resource manager. Okay, so this resource manager will control all the resources. Okay, so this will give this resource manager tool will give the blessings for all the sessions which are entering the database. I mean, it will control the CPU. It will control the limit of the CPU. Okay, if some session is just aggressively crossing 75% or 80% of the CPU, then this resource manager will say, hey, you are crossing the threshold. It is kind of a police in the database. Okay, so you can imagine if every session should be equally, the resources should be distributed equally to all the sessions, right? It's not that if one session is selfish and if it consumes all the CPU, then other sessions will be slow, right? So that is the main reason of using this resource manager. Okay, it will control the CPU utilization, and if someone is crossing the threshold, then it will just find the culprit and it will just say you should not use it. This is your limit. So like how a driver, a car driver who is driving on the highways, if he is crossing 100, right? So but the road speed limit is only 80 or 60. So there will be some road the police, traffic police or some police who will be there, and he will catch. Right, so similar to this. Okay, so now we need to identify the SQL statement. Okay, so every jobs or tasks that are happening on the database should be having some SQLs. Right, without any SQL, there is no reason of the database itself. Right, but now if I just query with the information, I don't get any SQLs. It says no row selected. Okay, so why? Because this is a collective job. This is not a single job which is consuming high CPU, right? So resource manager event itself is not it is not specific to any SQL. Okay, so it is a database level job or database level tool or algorithm which will cap all the CPU utilizations. Okay, so yeah, now we got all this information. Okay, so this gives us some idea saying that the CPU throttle, the CPU is not sufficient. Okay, the resource manager has throttled all the CPU because the some of the sessions are trying to aggressively consume the CPU. Okay, so now what you can do is, since you didn't get any SQL ID, you can just go and check the next wait event which is significant. Okay, so what you can do, you can just remove this class ID, wait class ID, just comment it. Okay, and then check what are all the other wait events next to resource manager. So now you got all the events. So if you see, the next one is row catch mutex. So you can just go and check for row catch mutex during that particular time interval. Okay, you should not change the sample ID. Sample ID will be same, but wait class ID should be changed, because resource manager is just a generic wait event. Even though you see significant, there is no SQL ID for that. So now you see when you searched for the event ID with row catch mutex, you got some SQL ID. Okay, so you can, this will give you some hint on what exactly is going on and who has exactly executed the SQL. So you can just check the SQL text, okay, to just understand what the SQL is and why it is taking it is consuming more resource. Okay, so if you see, this is just a system SQL. Okay, so there is nothing to focus on this. We'll see the next one. Okay, so this is also a system SQL. So these SQLs are just a consequence of the original SQLs that are executing. Okay, so these SQLs are not executed in the back end. Okay, so when you execute some SQLs in the front end, Oracle itself will get some data in the back end. So those kind of SQLs are there. So what you can do is you can again go to the next one, latch shared pool. So latch shared pool is also a generic wait event. Okay, so you will not get any much information in the latch shared pool. So let us just anyway check. So okay, so now you see, now you got the exact SQL. Okay, select full parallel for count of star from the table where payload is equal to payload like this one. So now we easily identified the exact root cause, right? So if you see the previous one, so you should be able to identify whether it is a back-end SQL or it is a front-end SQL. Okay, so if you get when you have more experience, you will be able to find out what exactly is this, because if you see here, it is a $v instance query. So $v instance is part of a database, so this will not take much time, right? So here also you can see it is sys auth $. This is a backend query. So these SQLs does not seem like an application query, right? And also yeah, so it is coming under row cache mutex. Okay, row cache mutex always occurs in the shared pool layer, and when there is when the mutexes, right? So instead of latches, Oracle has also introduced the mutexes. So internally the linked list and all those internal structures will be queried. Okay, so here in shared pool we have a dictionary cache, right? So dictionary cache contains all the internal dictionary related information. So all those dictionary cache will undergo row cache mutex. Okay, so when you have more experience, you will be able to identify this. Okay, so now when you went to the next event, you got the exact SQL. So you can also check the next SQL. So this is something different. This is not part of application SQL, right? So yeah, this is the root cause of the issue. So this is what we have executed in the job. Okay, so this is how we can triage or troubleshoot any you can say emergency issue. So if you are suddenly paged or involved in a call, right, and everyone were waiting for your input to identify what exactly is causing this, right? And you can use this fast method to check and provide the justification. So solution, that is something different. You cannot change what had happened earlier, right? So already the application team used parallel, and obviously using parallel will consume high CPU, that everyone knows. So in this case the question should be why parallel was used at this time, and obviously using parallel will cause high CPU utilization, and this is expected. So DBA cannot control these kind of queries, right? Okay, so if you need more in-depth and more hidden and secret sessions, right? So secret information or secret troubleshooting skills, right? So just support and like this video, and also comment if you have any thoughts in your mind. Okay, so I will give you more distilled information, and also the troubleshooting skills that I have got in the future videos. Okay, thank you for watching.